We're going to learn about rotations in this video. Rotations is a specific type of transformation where the object you see is going to turn either left or right around a center point. So this one is turning right, and this particular shape was turning left, and we're going to see how the coordinates change as it turns. This is a chart that I like to use. I call it my cheat sheet or my reference guide. And what we're going to be looking at is when the shape is turning either counterclockwise, that means it's going to go to the left. The shape is going to go to the left. Or if it's going clockwise, then just like the hands on a normal clock would turn, then it's going to turn to the right in the coordinate graph. So the way I have this set up is it's counting increments. Every box is 90 degrees. The original shape, the rule or the generic setup is X comes first and Y comes second. So now I'm going to show you what the rules would be, the algebraic rules to perform any of these rotations. I'm going to start at the bottom. On 360 degrees, I've put out to the side. If you go 360, you make one complete turn all the way around. So everything is going to stay the same. It's going to be back in its original location. So that is just going to be X, Y. Okay, the next one I'm going to do is 180 degrees. No matter if it's counterclockwise or clockwise, you're going to make two turns to the left or two turns to the right. You're going to go to the same spot. So since these numbers are the same on both sides, the way I remember this rule is X and Y still stay in their same position. But instead of me facing maybe to the left, a 180 degree turn makes me go to the right. So I'm going to put a little negative sign in front of this. If you watched another video I had previously, we talked about these negative signs in front of X and Y do not mean that the value is always negative. When you reference back to the original coordinates, X, Y, if I put negative in front of this, it means I want the opposite of what it used to be. The other two rows on the table are combinations of 90, 270, or 270, 90. So here's how I remember this. 90 and 270, they switched places in this chart. Therefore, the rule is X and Y need to change positions in this chart. So Y is going to come first, X is going to come second on both of these. Y is going to come first, X is going to come second. Now, the thing that you have to kind of remember is in this first row, if you set it up with counterclockwise being on the left, clockwise being on the right, this first row, not only are the coordinates going to switch positions, but this first letter, the coordinate for Y, is going to also turn the opposite of what it used to be. So the rule is going to say negative YX. And then the opposite thing is going to happen down here. They've switched positions, but now the X value is going to be the opposite of what it was the first time. So it's going to get a negative sign in front of it. A few facts about rotation. A rotation is a type of transformation that turns around a fixed point. It's called a center, or it's called center of rotation. And most often it's rotated around the origin. When a figure is rotated, the image will maintain congruency. It's going to stay the same size, but not the orientation. So the direction that it's facing, it will change. Change direction. And that is a D. Okay. The next part, it says rotations may be clockwise or counterclockwise. Clockwise or counterclockwise. They're most often measured in degrees of 90, 180, 270, and 360. You can have other amounts, but those are the four most often used, at least for me, with my students. Knowing the direction that clockwise and counterclockwise means is super important. Clockwise means you're going to turn to the right, the normal way a clock works. And then counterclockwise means you're going to turn to the left. You would go the opposite way of a normal clock. We're going to look at an example of some of the different rotations. The triangle at the bottom in each one of these examples, this is the original. So I'm going to shade this in to say what the starting point was. I'm going to label the corners of the triangle so I can see which way it's turning. I'm going to put 1, 2, 3. Then in this first box, if it makes one rotation, my numbers now would be in the position 1, 2, 3. Moving on to this 180 rotation. Again, I'm going to number them the same way. 1, 2, 3. This time, 180 degrees means you're going to make 2 turns. So there's 1, then 2. And then if I number these, I'm going to be numbering upside down, just because that's the way the shape is going. So 1, 2, 3. Okay, 270-degree rotation. This one is modeling 3 turns. Then if I number the original shape, 1, 2, 3, then the way it's going to end up, 1, 2, 3. And the last one is representing a 360-degree turn, which in the previous slide I talked about that, meaning the shape stays the same. So you're only going to see one picture. You're not even going to be able to see the second one because they're directly on top of each other. Now what we're going to do is we're going to take a shape that's in a coordinate grid. We're going to apply the rotation that it wants to happen. I'm going to graph it on the coordinate grid, but then I'm also going to show you how to record what the rule would be for that type of rotation, and then write in the new coordinates as well. So originally, this shape, point A, is 2, 2. Point B is 6, 2. And then point C is 5, 5. Now this says we want to perform a 90-degree clockwise rotation. 90 degrees clockwise rotation, that is going to be the right side 90 degrees clockwise. The rule that I need to follow, the algebraic rule, says y negative x. In the table, I'm going to put that down. Y and negative x in all 3 spots, so I can do all 3 coordinates. Now, the original number for A was 2, 2. So it's the same digit, so that doesn't really matter. 2 is still going to be my numbers. However, my x value used to be 2. When it moves to the back, it's now going to be the opposite of what it used to be, so it should be -2. I'm going to make this a little bigger so I can write on it easier. My new coordinates would be y comes to the front. It's +2. X is going to go to the back. And now it's the opposite of what it was. So just reviewing that one more time real quick. For coordinate B, okay, 2 was the y, so it moves to the front. X was 6. It's going to move to the back and be the opposite of what it used to be. -6. And then for the last coordinate for point C, it would be 5, -5. Now I'm going to graph it, and we're going to see and make sure that it really did turn one box to the right, because clockwise goes to the right. Okay, point A should now be 2, -2. 2, -2. Point B should be 2, -6. Have to move that up a little bit. 2, -6. And then point C should be 5, -5. And then if I connect these the best I can, and put in the letters. Okay, A is still going to be closest to the origin. And when this moves around one complete box, B is now going to be closest to this axis. And then C would still be there, kind of floating in the middle. All right, quick review of the chart of how you fill it in, just to hopefully get people on the right track here, especially for my class. 360 is complete turnaround and be the same, so X, Y. 180, you just move from one side, you're going to look to the opposite side, so it's still X, Y, but they are the opposite of what they used to be, so put in negative signs. Then when you have 90, 270, and then it switches to be 270, 90, the X and Y coordinate are going to switch. So now Y is at the front and X is at the back on both of those. In the first row, when you're doing 90 degrees counterclockwise, the Y is going to be the opposite of what it used to be. So the rule is going to have a negative sign with the Y. And then when you get down to the third row, the X is going to have the negative sign in front of it. So now if I have no picture and all it wants me to do is write the algebraic rule, which is what this says, write the rule for a rotation of 180 degrees. Okay, it doesn't matter 180 on either side, it's the same thing. I'm just going to be the opposite of exactly what I used to be. So when it says X, Y, now the new rule is just going to be -X, -Y. Opposite X, opposite Y. The second one says I want to do 270 clockwise. So here's clockwise. The rule for 270 clockwise says change positions, because anytime you have a 90 or a 270, X and Y switch spots. Y would now move to the front, X goes to the back. And then in this particular one, clockwise 270 says Y needs to be the opposite of what it used to be. So I'd put a negative sign in front of Y. So that algebraic rule is -YX. In this example, we're gonna do 90 degrees counterclockwise. So my chart counterclockwise is on the left, and 90 degrees is that first box. So actually, this one's going to end up having the exact same rule as the last slide. Even though it was 90 and 270, they match up They match up in my graph right here. Ooh, it looks like my chart's not filled all the way out. Let me zoom in and fill that out real quick. 360 stays the same. 180 switches to be the opposite. And on this one, okay, so now I'm good to go. Whoop. Okay, so rule one more time is negative yx when I put this in my table. Negative yx. And for me, writing it in this table right underneath the original coordinates helps me make sure that I put the right number in the right spot. Now, the original shape, A is at point -8, -3. Point B is in -3, -3. Point C is -3, -6. And point D is -8, -6. Now, if I perform this rotation, it says my Y value needs to come to the front and be the opposite of what it used to be. So -3 now is going to be in front and the opposite. So the opposite of -3 is +3. And X used to be -8. It's going to go to the back and it's going to keep the same as what it was originally. So now I'm going to do the same thing with all the numbers. -3 was the Y. It's going to come to the front and be the opposite. Now it's going to be +3. And then the X value was -3. It's going to switch to the back and be the same as it was originally. Point C, -6 is the Y coming to the front, changed to be the opposite. Now it's +6. X value was -3 and it goes to the back and stays the same, so -3. And then coordinate D, -6 was also the Y, moved to the front and become the opposite, +6. And -8 scoot to the back and be the same. Okay, now I'm going to graph this. Point A is now going to be +3, -8. Point B is +3, -3. Point C is +6, -3. And point D is +6, -8. Then I'm going to connect those. I'm going to fill in the numbers so I can actually see how it was turning. All right, remember A was 3, -8. So A is down here. B was 3, -3. So B is now here. Also notice that B was the closest to the origin. So when the shape turns, B needs to still be closest to the origin. Point C was 6, -3. And then point D was 6, -8. And again, this has made one rotation to the right. Okay, filling this chart in again one more time. Just super good practice for you guys. 360 stays the same, X, Y. 180 stays the same, but each value becomes the opposite of what it used to be. 90 and 270, they switch spots because they switch spots in my chart. And the first row, Y is going to be the opposite of what it used to be. And in the third row, X is going to be the opposite of what it used to be. And if you're in my class, we are going to memorize this chart. So, yay, get ready. The first one says write the rule for a rotation of 180 degrees. 180 degrees says X and Y keep their position, but they need to be the opposite of what they were originally. negative x, negative y. Remember, it just means the opposite, not always negative. Then the second one says write the rule for a rotation of 270 counterclockwise. So we're getting to do a different one this time. 270 counterclockwise. So counterclockwise, 270 says I should go y, negative x. So remember, anytime it's 270 or 90, switch positions. It's kind of hard to remember sometimes which one's supposed to be negative or the opposite. So that's why I make this chart for myself, because then I can just look at it. All right. There are your algebraic rules for rotations.